In part 2 of this tutorial, we are going to make the turtle go in one of 4 directions, and we're going to establish borders for our play space so that when the turtle reaches the borders, the game will end because it's illegal. All right, so for the first thing, we need to draw a game board as the kind of the first step of the program. So I'm going to create a routine. Now I could just do the steps to create a board, but for a lot of different reasons, if you have a specific job that you want to get done in a program, a lot of times it makes sense to write it as a function so that you can call it in your program wherever you need to in case you need to do it over again. Also, by naming that function, it's clear to anybody reading the code what it is that you're doing at that step in the main part of your program. So near the top of the program, I'm going to define a function, draw borders, that draws the borders of the play space. All right, I've written the draw borders routine here, and I'll describe what it does. It's sending a bunch of commands to the turtle. It's setting its speed to 0 so that it moves quickly. It lifts up the pen, moves the turtle to position -200 and 200. So that would be -200 is in the X direction, so it moves it to the left, and 200 up is positive in the turtle drawing world, so it moves it vertically 200. So it moves it to an upper left-hand corner. Then it puts the pen down, and then it moves the turtle forward 400. So when the program starts, the turtle is pointed to the right, so it moves forward 400, and then it turns the turtle right 90 degrees, and it does that 4 times. So it draws a line that's 400, and then a line that's 400, a line that's 400, and a line that's 400. 4 times. It draws a square, lifts the pen up again, puts the turtle back to its origin, which is 0, 0, and then puts the pen down. So when we run this program, it doesn't draw the border because we haven't called it. So let's stop that. So I'm going to rearrange this program a little bit. So this is really the beginning of the main part of our program. So I'm going to keep the main part of our program all together. So I'm going to have a section up here. So I'm going to cut that out, and I'm going to copy, I'm going to put that getting a reference to the screen right before we do the key binding. So right there. Okay, so I'm trying to put all of my function definitions together in the same place. So here we go. So remember, these were, I'm going to put a comment here. These were the let's call the turtle in this case a sprite. So I'm going to call this sprite behaviors. So in this context, a sprite in a game is kind of like a game character, something that acts in our game that we can move around. So the turtle right now is our sprite because it represents the head of the snake. So right now these are the behaviors of the head of the snake. And okay, actually, so done is kind of a behavior too, because so done is when the program is over because someone hit an X. And let's see, go left. And so these functions are the responses to the user input. And game setup. Okay, so now I've just got some comments on the different sections of my program. And we are going to, whoops, here, down here, we're going to say that below here, it is main part of our program. Okay, why is this significant? So it's significant because when this program runs, the first thing it does now is defines a bunch of functions. Now, as you've seen before, when we define functions, it doesn't actually run the code that's in the functions. So in other words, just because this definition, this define here, is at the beginning, doesn't mean it draws the borders at the beginning. It sets up the drawing of the borders. And it sets up these function definitions to respond to the go left command from the user or the go right command from the user. It sets up these functions that tell it what to do when the program is so done, when the program is telling the sprite to do a tight circle left or tight circle right, these behaviors the sprite will execute. And then once those function definitions have all been set up so that we have the functions, now the main part of our program is down here, and this is where we actually see things start to happen. So we get the screen from the turtle, we set the background color, and then right here, for example, now we will call our draw borders. And so this is where draw borders actually finally happens, because this is where the call is. So the first thing that happens is we get the screen, then we set the background color, then we draw the borders in that order. Okay, let's run it and see. And there it is. It's a small game space. And if you're doing this and you have a larger screen to work with, feel free to use different numbers than than the numbers that I use. I've created this so that each side is 400 units long. So this is a square that's 400 on a side, because it just so happens to fit into the screen I have here. That I think is decent for this video, but you can choose another size. So think about how you would make your square a different size. You might want it to be wider than it is tall, for example. That might make sense rather than having it be a square. Definitely choose the numbers that you would prefer. We are a little bit limited in Replit in that we have to exist within this space, right? But for the purposes of this game, we will, or for the purposes of this tutorial for the game, I'm going to exist in this small space, and we can recognize that we could make it bigger if we wanted to. Because when we ultimately play the game, of course, we can do this, right? We don't need to see the code. So I could make this much bigger if I wanted to, but for now, I'm leaving it this size. Okay, so the default behavior for the sprite was to circle left. So that's what it's doing here. It's doing the circle left behavior, and if we want to change this so that in our game, what's going to happen is the sprite is, or I should say the head of the snake is going to go in one of four directions. It's going to go up, down, left, or right, and it's going to continue doing that instead of going in a circle. So let's create new behaviors for our sprite. These behaviors will be, I'm going to call them step left, step right, step up, and step down. Okay, I've decided that step right will look like this. So we're going to set the heading so that the turtle is facing to the right. That is a heading of 0 degrees. And then I'm going to send the turtle forward 5 units. And so I'm going to make a routine similar to step right for each of the different directions. So step right, step up, step down, and step left. Okay, in order to just test this out, so right now I've got these different behaviors, right? I've got the ability to step right, up, down, and left. But right now we're still tight circling left as a default, because if we look back at our game loop, while it's not done, while not turtle.done, we are going to check if the behavior is to go to the right, and if it's not, we go to the left. The left is kind of the default. So what we're going to do is we're going to change the default to be, as a test, we're going to change it to be step right. And we're going to stop and run the program. And now we can see that it goes forward to the right. Okay. So now we would like it to, instead of only having the choice to circle right or circle left, we actually don't want it to circle at all anymore, so we can get rid of our circle behaviors. And then we can change the decision structure in the game loop to execute the remaining behaviors. Okay, so now during the while loop, if turtle.behave is set to up, then it's going to step up. If it's down, it's going to step down. If it's left, it's going to step left. And if it's right, it's going to step right. So now we have to change so right now we still have keyboard control that's just L, R, or X. So we need to add in the possible keyboard commands to change the direction of movement. And so the traditional direction keys are W, A, S, and D. All right, so now this, so what these are doing is to set up the bindings associating the keys with the routines or the functions that will change the behavior, that will tell the sprite to do different behaviors. So W will be go up, A is go left, S is go down, D is go right. So we don't have these routines because we just created the idea that we were going to have them. So up here, where we have go left and go right, which were the circle behaviors, we now want to change what these do. Actually, let's see, we already have a left and a right, right? Yep. So we want to add up and down. We're reusing the old commands here. So left used to mean circle left, and now it's going to mean move to the left. So we've got left, right, and we now want up and down too. And all these do is store the desired direction that the sprite is going to go. And we've got some debug print statements in here for when we're moving. Okay, so now the keyboard can now tell the mouse to, or tell the sprite to go left, right, up, and down. And we have actual behaviors to handle those. We set the heading in different directions, and then we move the mouse forward in the desired direction. And so the way our program works now is we set up the screen, set the background color, draw the borders, set up the screen to listen to keys W, A, S, and D, and X. And then we set up the game loop here. We have a default behavior which is left. Let's make it right. Default behavior is now to go to the right. And then in the loop, we are going to continue to go either up, down, left, or right. depending on what our current direction is, and it starts out to the right until the program is over. Okay, well, let's run it and test that. So I'm going to have my hand over the WAS and D keys. So WAS is down, D is right, A sends it back, W is up, D is right, S is down. It seems to be working. And we are drawing. And then if I hit X, the game ends and it stops drawing. All right, we've got a sprite that moves, which is great. I'd like to add one more thing. We can make this a little bit more game-like, at least for now. We can make it so that the if the sprite hits the border, you can see we hit the border several times because we don't have a lot of space here. But we can make it so that if the sprite hits the border, the game is over. And we can print at the end here, print game over. You hit the border. And that's what will happen when the game is over. How do we determine whether the sprite has hit this border? We don't have a, I don't have an idea yet how to check the wall, but I know I'm going to have to do it every time through this loop. So what I'm going to do is write a routine called check collision with wall. Okay, so do you see what I've done here? If I run this program, it's not going to run now. It gets an error because when it sees check collision with wall, it's saying it's not defined on line 94. We haven't written that yet. But sometimes when I want to do something in a program, I write the call to the function first, and then I go and write the function because I know that this is what I want to do in the while loop. I just haven't figured out how to do the collision with the wall yet. So I've got what the function is going to be called, check collision with wall. I've named it, and actually the function actually describes what it's going to do. So that's one of the benefits of choosing a good function name. So in here, I will check whether the turtle has moved to any of the extents, of this game space. This is a square with sides 400 in length, but that means it's 200 in each direction. So if it exceeds 200 in any of the dimensions, it's actually collided with the wall. So that's actually fairly easy to check, right? So I can ask the sprite, I can ask what its position is, and so turtle.xcore and turtle.ycore give the turtle's position in the x direction, that's horizontally, and in the y direction, that's vertically. So for instance, if I want to know if this turtle has gone too far in the x direction, I'm going to check, is the turtle's position greater than or equal to 200? Because that is the edge of this square. Luckily, it's easy to check whether you've gone past the edge of a square because you only have to check one number in the x direction or to the left and the right, and then one number in the y direction to the top and the bottom. So let's say collided equals false. So we are going to assume that we haven't collided, and then if we find that we have collided, then we're going to set collided to true. So if turtle.xcore, that's the x coordinate, is greater than or equal to 200, then collided equals true. There it is. And then I'm going to do the same kind of pattern for all 4 directions. Okay, so x coordinate is greater than or equal to 200, or if it's less than or equal to negative 200, or if the y coordinate is greater than or equal to 200, or if the y coordinate is less than or equal to negative 200. If any of these are the case, then collided is true. And then I'm going to return from this routine the value of collided. So return collided. So in other words, temporarily it's going to store the value of collided, and when it's done checking every direction, it's going to return whatever it discovered. So if it collided, it's going to return either true or false, depending on what it found. Okay. So, so when it comes back, I need to store it as turtle.done. So if we have collided with wall, actually, let's not call it check collision with wall. Let's call it collision with wall. That way, this will sound more clear in the code. So collision with wall. Okay, so if collision with wall is true, then we're going to set turtle.done equals true. Okay, so if we collided with the wall, then we're going to tell turtle.done it's true, which is going to tell us not to return, not to repeat into this loop. So in other words, when it checks whether it should re-enter the loop, it's going to decide not to re-enter. Okay. Let's try running this. And let's say I have an error, line 63. Collision with wall. Oh. Forgot the parens. Okay. And I forgot the colons here. Having some syntax issues. Okay, now this should run. All right. See the problem here. Okay. All right, now it runs. All right, so I'm going to keep my hand over the WASD buttons. So run it, WASD. Will it end when we get to the bottom, though? Yes. So that's a collision with the wall. We can also let it go. Okay, that's a collision with the right wall. So this is some testing, collision with the top wall, and collision with the left wall. Okay, so I will share this code with you in this activity. And what I would like you to do is change this program so that the sprite cannot turn around 180 degrees. So right now, when you run the program, the sprite can turn in any direction, but we would only like the sprite to be able to turn 90 degrees. So the sprite should not be able to, so eventually this is going to be a snake, so the snake should not be able to turn back on itself. So you're going to have to find a way to restrict the user's possible commands. So at the point where you process the user input, you have to figure out how to stop the command from doing anything if the command that the user is trying to give is an illegal command. For example, if the snake is going up, then when if the user tries to give the command to go down, then you want to prevent the user from giving that down command. But if the snake is going up and the user tries to turn it to the left to go left, that's a legal command, so that should be fine. So that is the extension that you should work on to this program. Okay, have fun solving that problem.